morning students, hearty welcome to Adarsh Vidyalaya Matriculation Online Class, Class 8. Subject Science, Unit 3, Light. Today we are going to see the topic Snell's Law and Dispersion of Light. First, let's enter into the topic
Snell's Law. We know that light travels in a straight line through any medium of uniform density. However, the speed of light depends on the nature of the medium in which it travels. Distance moved by light in a given time in different media. When light travels from a rarer medium to a denser medium, its speed decreases. Whereas, speed of light increases when it travels from a denser to a rarer medium. It is due to this change in the speed of light that the ray of light bends as it goes from one medium to another. Thus, the change of speed of light as it travels from one medium to another is the cause of refraction. Refraction occurs right at the interface of the two media, and the angle of bending of a ray would depend upon difference of speeds of light in two media. AO is called incident ray. OB is refracted ray. NON dash is called normal to the plane surface XY, separating the two media. Angle of incidence represented by I, angle of refraction represented by R. Angle for refraction R is never equal to angle of incidence I except for normal incidence. The incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. In fact, the ratio of sine of the angle of incidence to the sine of the angle of refraction is a constant for the light of a given color and for the given pair of media. This law is also known as Snell's law of refraction after the name of its discoverer, Willebrord Snell. And this constant is called the refractive index of the second medium with respect to the first. The direction of the bending of light depends upon the optical density of the two media. In going from an optically rarer to a denser medium, the ray of light bends towards the normal. When light travels from an optically denser to a rarer medium, it bends away from the normal. When light is incident normally on a boundary of two media, no change in direction of light occurs. No refraction occurs at the boundary that separates two media of equal refractive index.
Dispersion of light. In this module, you will learn about the dispersion of light. Sometimes after the rain, we see rainbow in the sky. It looks spectacular, doesn't it? Do you know how a rainbow is formed? A rainbow is formed due to the phenomenon of dispersion of light. To understand what dispersion of light is, let us perform an activity. For the activity, you need a prism, a white sheet and a cardboard with a small hole at its center. Place the cardboard at a position such that the sunlight falls directly on it. Next, keep the prism such that the light passing through the hole of the cardboard falls on the surface of the prism. At the other end of the prism, fix the white sheet as shown. As the sunlight passes through the prism, you will observe a beautiful band of colors appearing on the white sheet. If you look at these colors of the band from the bottom, they are in the order violet, indigo, blue, green, yellow, orange and red. This sequence of colors can be remembered by the acronym VIBGYOR. The light coming from the sunlight was white light. Are you wondering from where this beautiful band of colors appeared? Actually, the white light consists of 7 colors, namely violet, indigo, blue, green, yellow, orange and red, which we saw as the band of colors. When the white light coming from the sunlight falls on the prism, it splits this incident white light into its constituent colors. The splitting occurs because different colors of the sunlight bend through different angles with respect to the incident ray when they pass through the prism. The red light bends the least, while the violet bends the most. Thus, the rays of each color emerge along different paths and become distinctly visible. Thus, we are able to see the beautiful band of colors. This phenomenon of splitting of white light into its constituent colors through a prism is known as dispersion of light. The band of constituent colors is known as spectrum. This phenomenon was first discovered by Sir Isaac Newton. Now that we have understood what dispersion of light is, let's understand how it causes the formation of a rainbow. A rainbow is generally formed when the sun appears just after it has rained. At this time, many water droplets are present in the air. When the sunlight passes through water droplets in the atmosphere, each water droplet acts like a small prism and refracts the incident sunlight. As soon as the sunlight enters into the prism, that is, the drop, it splits into its constituent 7 colors, VIBGYOR, within the drop. When this band strikes the other edge of the drop, it gets reflected internally towards the first edge of the drop. As the band reaches the first edge, it gets refracted again and finally comes out of the raindrop. This band of colors which finally comes out of the raindrop is what we see as rainbow. A rainbow is always formed in the direction opposite to that of the sun. Thus, the appearance of rainbow in the sky is due to the dispersion of sunlight by the water droplets present in the atmosphere. Dispersion of light not only results in the formation of a rainbow, but we can see this effect in our day-to-day life as well. For example, the beautiful band of colors we observe in water fountains, soap bubbles and CDs are all due to dispersion of light. Let's recap. The white light consists of 7 colors, namely violet, indigo, blue, green, yellow, orange and red, VIBGYOR. The phenomenon of splitting of white light into its constituent colors through a prism is known as dispersion of light, and the band of constituent colors is known as spectrum. Formation of a rainbow and beautiful band of colors observed in water fountains, soap bubbles, CDs, etc. are all due to dispersion of light.
I hope you all understood the topic Snell's law and dispersion of light. Thank you, students.